Good morning, everyone. Am I audible? Yeah. Okay, good. So, welcome back. And so today we are going to start Fractal 3. So this is more like a warm up lecture, not keeping it rigorous for these two lectures. Something which we will discuss, and some reading material I will provide, and you can and then start rigorous discussion around planning and more things from the next week. But these two lectures will be essentially like discussing something which you already know, maybe, and something which is already covered in part of AI 1 and AI 2. But more like an interactive discussion. So let me share my screen. Hey. Just let me move. So I hope you can see my screen. Yeah. Okay. So again, good morning, and I wish you a very happy New Year. So let's get started with Fractal 3. More like warm-up session, as I said. So what are we going to do in this fractal? Am I clearly audible, right? Any? Yes. So what we are we going to do learn in this chapter is first two lecture I just said, like so already like first weekend, and after it's a New Year mood for everyone. So I said, like, I will not make it more rigorous, but it's more like setting up some context uh, and discussing what you may be already knowing. Then a few lectures on planning, like some graph planning and partial order planning. I also want to spend some time on this is not in your syllabus, but this is something which is emerging, and I thought it's worth learning. So this is called AI habitat. It's more like a robotic environment, virtual environment, and we can look into this and try to connect whatever we have learned in this course with that practical thing. So this is CBPR workshop from last year on AI habitat, and this is like a virtual environment for moving robots here and there. And then maybe I will discuss something on knowledge representation. Right. So, how do we evaluate? So we'll have like in-class quiz, maybe not in these two lectures, but from the next time. So we'll have like total four quizzes. Best three will be considered. So that will have some weightage, as discussed already, I guess. Then we'll have a handwritten assignment, and this time trying to make it slightly different. These handwritten assignments are like you can work in a group, right? So you can form a group of three and work in a group, submit in a group, and discuss among yourself. Uh, so this will be released around Jan 10, and you'll have like 15 days. For early bird deadline is January 25th. So you have to, if you send late, if you do late, there will be some penalty. But by January 31st, you should submit anything anyway. And this will be like some mostly like handwritten assignments. So some questions also may repeat in your essay. Uh, Last is the end semester exam, which will be like again majority of that will be Fractal 3. Okay, so now so this is something not for this class only, but entire uh, program. So this is the proposed schedule. If you have any feedback, you can let me know, because this is what was decided. January is 27 to 31st. We can keep exam, and keeping everything on weekend will be like too much of a load, I thought. So this is what I'm thinking. If you have any concern or suggestion, you can let me know in a couple of days. So 27 and 28 are weekdays, but then maybe you need to take off or something so that you can do, because this is like pre-announced. And 30th, 31st is Saturday, Sunday. This is not AM, this should be PM. Okay, this should be PM. Okay. Okay, any question, any concern so far? All right, so let's then move to the discussion. So, what is an AI, right? So, this is maybe you have been uh, discussed multiple times, or multiple ways of discussion might have happened um, in first semester as well, as well as second semester. So, I'm going to describe three, four notions of AI. And AI for me can be different from AI for you, or AI for someone else, right? So there are different ways of thinking what AI is, or defining what AI is. Some people think, or they believe that AI is not like something which we want to just mimic human in every way, like every possible way. But we are more interested in designing some assistants, right? So, like Alexa, for example. So, Alexa is an AI agent, or AI, yeah, you can say it's an AI agent. But does it have a behavior like human? Uh, that's a question, right? So, there's this question there is a question maybe you guys can answer. Does Alexa behaves like human? Anyone? Yeah, so some may say yes, some may say no. So behaves like human is to some extent maybe yes, right? So like if ask some instruction to let's say Alexa or Google Assistant, I never used Alexa myself, but I use Google Assistant. So if I ask Google Assistant to set an alarm, it will do that task, and for that particular task it's behaving like human, at least externally, right? I don't know how internally it is doing. Does it thinks anything or not? But in some certain circumstances, when there is some critical decision has to be taken, these assistants may not behave like human, right? So they may not be doing thinking, for example. They may not be, uh, they may not be, what do you say, in a critical environment. If there is a fire in your home or somewhere, they will not run away. So, or they will not do something like maybe they can do some fire alarm, maybe that's also possible. But sometimes if it is an unknown or unseen environment, they may not able to behave like human. But to some extent they do it, right? So the thing is, this notion of behaving like human is also kind of a subjective, and it's like what do you say? You're not behaving like human is also can be seen from externally how it is behaving. So if it is following all the orders we give, or some following some rules, then okay, this looks like externally it is behaving human. The other model is like internally it is be operating as a human, right? So behaving and operating, two different things. Internally operating as a human means then it should operate how human brain works, right? So that's also like from the cognitive science angle, people research on that direction where how human brain works and try to mimic that. So, for example, when I talk about AI, I'm more excited about the first part, as I do not work cognitive science angle, so I more focus about okay, even if it operates in some way, but if it behaves like a human, right, or it behaves like a human to some extent also, in order to help human, that's okay. But then there are group of researchers who are worried about the second part as well, and that also has importance. It's not like the only thing is this behaving is important. How operations are done, that is also important. So I will anyway also share one very nice article today, which you should definitely read about this. Uh, so another thing is computational models that behave intelligently. Right? So that's another notion of intelligence. Now this is also very difficult to define what intelligence means. Right? So this is also can be sometimes subjective, and for you, if something is intelligence, uh, it's, it may not be intelligence for something someone else. So another notion is behaves rationally. This is very much accepted notion of AI, like computational model that behaves rationally. So given certain amount of knowledge, it should act in certain way, right? So it should act to maximize the success rate. Then we say that it's a rational machine and a rational model, and then that's one way of defining AI. We'll talk more about rationality today. So another, or I think this is the origin of AI is this Alan Turing's test, right? So Alan Turing's test says that okay, so you have here you have a machine. Let's say I don't know whether it's a machine. So A is one participant, B is another participant, and you are C, right? So you are here, and you do not have you have not seen whether who is inside this room, who is inside this room. So what you only have access is like you give some question to this both these guys, and let's say you give a handwritten question, so some question, and you expect some answer. And by looking into that answer, you decide which one is a person and which one is a machine. Right? So that's another notion of artificial intelligence, and that is like to some extent, people are able to break this, not always, means for some tasks, right? So if you have a, let's say, simple question answering task, it's very difficult to figure it out whether it's a human answering or whether it is a machine answering. Like, so we talked about Alexa, for example. So when you give a question like who is the prime minister of India, Alexa will say Prime Minister Modi, and even a person will say like that. So given for some certain tasks, this Turing test is, you can really determine that machine is also passing. But in a larger schema, that's still beyond the current AI capability. Like we cannot say that machines are as intelligent as human as of now, right? So This is one of the very famous tests for artificial intelligence. So this is also said like no AI ever works. If it works, it's not AI. This is another interesting way of to look into AI. So, like, let me take an example. Like when this compilers came, so compilers were also like people are thinking, okay, this is some kind of intelligence or artificial intelligence. Right? So compilers are like interpreting the um, high level languages, like higher level languages like CE and all, and interpreting and then doing some task. So that interpretation itself is not something at that time, like maybe in 1950s and also on, no, not 1950s, 1960s, 70s. Okay, this was challenging enough task considered that time. But after that, so many compilers are there now. So compilers are no more AI, right? So whatever start working, people say that's not AI. So what is an AI, right? So maybe that's a question in the next slide. So I think so. What I made is you have to go to slido.com and there's just some experiment I'm doing. How does this look like? You can and enter this code 8864 at slido.com 8864 and you will get this question. Let's see if I can run it using Slido. Slido. Just a minute. Yeah, so then I can see who is answering at least and get a feel like, let's see. So you will have 5 minute time. Give some examples of AI technologies like we have discussed some. Let's get more. Okay, so let's take a 5 minute off here and I would expect some answer here. So you can see the question in slido.com. You can't see, now you should be able to see because this is a tick poll. If you go to slido.com, yeah, there is already some answer, Alexa, but we would like to see more such. Like you can also talk about some upcoming technology, whatever it is. That is, warehouse delivery and pickup robots. Yeah, means that's also there. Automatic speech recognition, machine translation, speech synthesis. Big mind. Yes, so that's already six people have answered. Eight. Face recognition with age variation. Yes. AlphaFold. I don't know what is AlphaFold. I am not aware. Sorry. So maybe can you describe someone who has answered? What is AlphaFold? Siri, yes. Autonomous machine systems and virtual assistant. Yes, so that's good. Yeah, so thanks. We have like this good number of response. So maybe next. So driverless cars, yes. So there are many such AI technologies, right? And you can try fitting these technologies. So I'm ending this poll. Uh, you can try fitting your these AI technologies after this class to figure it out how they fit in the definitions we discussed today, or which among these do you think do not fit in the definition? You can start thinking about them. All right, good, thanks. So let's move to. We'll have more questions today. Okay, so let's move to some more discussion. So we said artificial agents, right? So, or sometimes we say artificial agent. So what is this agent, right? So agent is like, I think this is, I have written here software, but it should be like software or hardware that gathers information, right? So it should be not just software. Agent can also be and hardware that gathers the information about an environment. Now we'll talk what is an environment, and takes action based on that. Right? So an agent in this artificial uh, intelligence is one of the important central concept, and it is nothing but software or hardware that gathers information about an environment, and the environment where it is working, and takes action based on that, right? So for example, if you are talking about self-driving car, the self-driving car will have an environment, right? So if self-driving car is moving inside IIT Jodhpur, then IIT Jodhpur will be its environment, and that self-driving car will be an agent, right? So that's a notion. So robot can be an agent, a web shopping program can be agent, factory traffic control systems, all this, whatever we are talking, or whatever examples you guys also already gave, they are kind of an agent. Now, what is an environment? How do the agent and environment interact? So, agent and environment interacts as follows. So, agent percepts from the environment, right? So, percepts means either, so agents will always have some sensory inputs, right? So, some sensor devices, whether it's a vision sensor or speech or maybe the touch sensors. So different sensors, different ways of taking input, right? So this is very similar to how a human behaves or human works in this planet. So for example, what we do, we see something, we hear something, and based on that, we take some decision or take some next step, right? So these are the two things happening. It takes the input and performs some action. Right, so this is agent and environment relationship. So when we model some artificial agent, these are the three things we do. One is action space. So we'll have some set of actions. Now, this set of actions, in case of different AI things, it will be different, right? So, if you are talking about, let's say, a robot moving inside your house, it will have certain set of actions, maybe like move left, move right, turn or turn left, or move forward. So these are action space. So a robot moving inside your house will have certain action space. Self-driving car, for example, may have some different action space. Right? Percept space is again like what you perceive. right? So, like what are the inputs you are taking from the environment, and of course the environment itself. So these three together makes the a world model. Now coming back to the thing which we started discussing is the AI should behave rationally. We said. Now what is this rationality? What is this notion of nationality? Let's discuss here. So, an agent that takes action it believes will achieve its goal. Okay. So it takes that action which it believes it achieve its goal. So every agent have certain goal to achieve, right? So they are not purposeless machines. They have some goal to achieve. So every machine learning or every AI agent have some goal to achieve. For example, if you talk about Alexa, what is the goal of Alexa? Alexa's goal is to satisfy the information need of human being, right? So it has that goal, and whatever it does, it has to keep that in mind that you should maximally satisfy the information need of. So if or Google search engine has similar goal, the self-driving car has a goal to reach the destination and like safely, right? So safety is important there. You should reach the destination and you should not hurt anything or anyone, or you should not crash. All these are goals, and any agent you can think, like we have talked about many agents, or you have guys have given a lot of examples. You can again try to connect. Every one of them has some goal to achieve, and for achieving that goal, you need to take some action. So that the rational agent takes action, which it believes will achieve its goal, right? So if a self-driving car is running in the road, let's say, it should not take a action to let's say hit a pedestrian, right? So that's not something a rational behavior. So, but a rational agent that takes action that believes will achieve its goal. Another example, let's say you don't want to get weight. So this is your goal, right? So, or say that there is a robot which has a goal that it does not want to get weight. So if it brings umbrella always, is that a rational behavior? It's a question. So not getting weight and you are bringing umbrella always, is that rational? No, yes. If people are saying no, e- yeah, means if you are really bringing this umbrella always, it looks like okay, this guy is. Think about from the human perspective. Even like even if it is winter or summer, you are bringing umbrella, and that doesn't look like very intelligent person, right? So this guy is always doing. But what if you know that there is some, because there is you whatever decision you take, you should also remember this decision is not just you are taking on your own, right? So you have some knowledge base or some access to the environment, and based on that access to the environment, you take some decision. So that access to the environment was what we call is perception, right? So it can be either like let's say the weather prediction. So if the weather is rainy, then you are bringing umbrella. That is perfectly fine. But if it is weather is not going to, if the weather is perfectly sunny, and then umbrella getting bringing umbrella is not something very rational, right? Another thing is you, but if you don't know that whether it is or not, right? If you did not have access, then again, so then you can take umbrella in that way because you don't want to get wet. So both the answers are correct. I'm not saying that is not rational from the definition point of view. Of course, from the logical or our thinking point of view, we call something rational if it is looks like something reasonable and all, right? During monsoon, it is rational, especially in Mumbai. Yeah, that's what. So but from the definition point of view, it is still rational. We call because why we call because if you look into the definition, whatever tax action you take to achieve the goal, it's perfectly fine, right? Again, there is also a discussion like depends on the cost of bringing umbrella. That's also a good point. So these are just something like think while designing AI agents. I don't know. I think I should not discuss this, but maybe we can come back here. Okay. Another thing is like thinking, right? So why do we need thinking, right? So that's a question. Like, do agents really need to think, or can we program all the uncertainties, right? So this is another thing to discuss. Like people talk about there is, as I said in the beginning, there is a notion of bringing like or designing artificial agents or intelligent machines which can mimic human in every way, right? So it can think on your own, and it can take decisions on your own. It is not programmed decision, right? So that's another way of thinking. But do we really need a thinking, or we can program all the uncertainties? What do you mean by programming all uncertainties? So programming all uncertainties is, let's say, a self-driving car. Uh, Self-driving car, and in front of self-driving car, let's say an elephant comes, right? So that you might not never have thought of elephant coming in front of self-driving car, right? So self-driving car you might have programmed to recognize maybe pedestrians or some other cars or some other vehicles, because that's what you see usually in the outdoor environment or the streets. So if something like uncertain thing happens, right? Uncertain things, for example, uh, elephant coming in front of a self-driving car. In such case, how should it behave, right? That's something very hard to program, right? So when we say this, and again, what is this A star to P? Is we need to come back here. We're talking about this APE, right? So A star is all possible actions, and P is percept. So if you can program all possible uncertainties, then you may not have to really worry about thinking and all, right? Because you can actually program it well. But for some of these tasks, uh, you may not able to think about all possible uncertainties, and therefore people are talking about like thinking, or there is something also called not just thinking but maybe learning, right? So what if you do not have like learning is notion where what if you do not have much much idea about the environment or much knowledge about the environment when you start, or if the environment changes, right? So for example, we are sending a robot to Mars, right? So let's say that's a AI agent we are trying to make. We're sending a robot to Mars. But we do not know the coefficient of friction in the dust of the Martian surface. Right? So it's very much possible that you do not have such information. In such case, I know a lot about the world dynamics, but I have to leave a free parameter representing this coefficient of friction. So here, this is something where learning and thinking also things becomes important when we talk about an unknown or newer environment. In that newer environment, you might not have the entire world dynamics, everything known. Might have some certain parameters or certain things which we have to adapt there, which we have to learn there, right? So based on the prior experience, obviously. So this type of using that experience or prior knowledge and then adapting is also one way of designing AI machines, and like these are called like learning. So this is a question to think. I'm not going to answer right now. Maybe we should start thinking. Is what is the difference between thinking and learning? Let's maybe we can discuss it sometime in this course. But let's think about this. What is the difference between thinking and learning, and how this learning is different from the machine learning? Right? So when I say machine learning again, let's say traditional machine learning. So traditional machine learning is uh, you have similar distribution. You do not like really talk about this much uncertainties, right? So you do have some notion of uncertainties there, but when you design something like cat versus dog classifier, you only expect some kind of cat which is similar to training data, right? So may not be very, very different. But of course, then there are other notion of machine learning, like where you also talk about zero sort learning, where zero sort learning is something where you really do not know the distribution. The distribution which is at the test time is very different from what you train, right? So, if, for example, you train for cat versus dog, and during let's say testing, you are asked to test whether it's a zebra or not, right? So there, of course, you use some certain prior knowledge, like zebra has some certain features, and try to do things. So this is another way of learning, which is also like called zero sort learning. But all these things, how do you connect? Like try thinking. This is something you should now think. Different types of environment, and so one is the first environment is accessible environment. So what is accessible environment? Can you see the states directly? So if you observe everything, all the states directly, right? So all the states means all the possible things. That's called an accessible environment. So question, let's say chess, right? Chess is accessible environment or not? So if you're Yes. So if as we are playing, designing a AI for, which can play chess, and the environment there is accessible because you are aware of all possible states. So you have seen that, right? So these are, but maybe for something like let's say self-driving car. So self-driving car may not be accessible because you are not seeing all the states currently. The states you are you are not seeing everything, right? So you are at some particular position, and then you are moving. So everything is not accessible. The other thing is deterministic. So what is a deterministic environment? A deterministic environment is where an action map one state into a single other state, right? So if you are at certain state, right? you can on certain input, right? So this is something like if you have if you are at a state A and input is X, then you are going to B. That is zero, right? So if you are at certain state and if you perceive something, you are going to take a single decision, right? So you are going to take the certain decision, that is deterministic decision, not non-deterministic decision. For example, if you are uh, let's say the self-driving car is running. If there is a pedestrian coming, that's a thing. Then the next stage is like you have to stop that, right? So that's the example. So this is deterministic, but then you can think about non-deterministic environment as well. Static, static is like static versus dynamic. Static is can the world change while you are thinking or while you are really doing things? Can the world change? So if the world changes significantly, that's a dynamic environment. Like a static environment is, let's say, a robot moving inside a empty room, right? And like let's say empty room, it is moving and it is asked to do something like, okay, bring me a spoon from the kitchen, right? So if that is the task and the environment seems to be static because no one is nothing is changing. But if you are asking robot to, let's say, that's we are very far from this type of applications, but if I ask robot to go to the Jodhpur market and bring me some sandwich, so that environment is not static, right? So it is moving in an environment which is dynamic in nature. Many things can happen at this. So static environment, you need to program differently, right? So static environment, okay, so you can really program well for your like household duty or something like which is slightly static, right? So it can change based on some time and all. Like nothing is static in this world. Everything changes with time, but like you can think that as a more towards a static environment, but dynamic environment is like something which changes drastically. Like so anything. Another environment is discrete versus continuous. Right? So are the percepts and actions, both percepts and actions are discrete or continuous? So for example, chess game, it's a discrete environment, right? You have only set of actions, like the chess game, chess every night you can move in certain way, or all the things you can move in a certain way. Some certain rules are there, and that is what is action space. That's fixed, right? Finite number of actions. But like self-driving car, the actions can be vary. The percepts can also be not discrete. So that's discrete, and other one is continuous. If the environment is static, will the percept will be the same for different time steps given the same state for the agent? No, percepts will be same for different time steps. No, no, no. I don't think that's the notion. Percepts will change over different time steps, right? But what is happening is the entire environment is kind of a fixed environment, right? So that's better. Let us understand from the fixed and changing, right? So fixed environment is okay. The everything like is inside that environment is at fixed place, right? So there is a kitchen, there is a spoon there all these things are there, and nothing is really changing, right? So this environment is kind of a fixed, but changing environment is okay. Everything there is a road, but then there is a car coming from that side, this side. Many things are changing. So that's something dynamic. So static and dynamic, let us understand from the fixed environment versus changing environment. Okay. There are some more type of environments people talk is competitive environment. So what is competitive environment and what is collaborative environment? So competitive environment is it competes against another agent to optimize the output, right? So if you when I am saying another agent means there are multiple agents, right? And there are multiple agents and you are trying to compete against one another. So that's competitive environment. Versus collaborative environment is cooperates with each other to optimize the output. So example, like playing a chess is a competitive, like let's say two agents are playing chess. That's a competitive environment, right? So you are like playing against another agent to optimize, like you want to win. You don't want others to win. But a collaborative environment, like multiple self-driving cars moving in the street, that they have to cooperate to each other, right? So they should they should be optimize the output, like they should not crash each other and all such things. That's a collaborative environment. Single versus multi-agent, again, whether you're talking about single agent moving, very similar, like multi-agent if you are talking about multiple agents in the environment. So this competitive and collaborative only comes when you are talking about multi-agent. Right? So competitive and collaborative makes sense only in the multi-agent environment. Single agent, you are really not talk about this. Okay. So again, we will go to some questions. So I hope you can see these questions. Let's try to. So this has multiple. You can answer. You can start thinking. Chess is not an example of multi-agent. Yeah, let's see. Just say one answer. It's becoming like everyone is answering everything. No? Let's see. Okay, so let's start discussing now. So chess is the chess. If you okay, this question itself is kind of controversial. It seems if you're talking about chess, like which there are two people playing chess or two agents playing chess, then we can think like that's a multi-agent environment. That's two agents playing chess. But if only one agent playing chess with a person, something, then again also you can think that that is a multi-agent environment because one is artificial agent and one is human. So it's a multi-agent environment. So it's not a single. And it's also a competitive environment, right? It's not a collaborative environment. It's not an example of collaborative environment, but it's a competitive environment because the agent wants to win. Is it deterministic or non-deterministic? So deterministic is like you are at certain position, right? And your opponent is at certain position, right? That's what you perceive. Then your set of actions is finite and you are going to take that, right? So your set of actions at particular time is then again this is another thing which we need to think like this looks like a non-deterministic to me because uh, of course there are we need to think this more, I think. So let's say some like at certain state you are, you can, and then you can have multiple possibilities at that particular state, right? In that sense, if you start looking, it's non-deterministic. Collaborative, we have talked. Multi-agent, yeah. Yes. Okay, so next question. Self-driving cars running in road of IIT Jodhpur, right? Yeah, is an example of. Hmm, static. So, yes, those who are answering single agent, no, we're talking about self-driving cars, right? So there are multiple cars, single event, plural car. That's definitely not a single agent event. Static also is not correct. Why? Because inside IT Jodhpur, many things can happen, right? So people might move somewhere, so it's not a static. It is accessible environment. So again, that's doesn't seem to be correct to me. I don't know. How do you say accessible? What is the again? Are something which outsiders cannot access. No, accessible environment is just like you have access to all the roads, right? So that way, if you are start thinking accessible, yes, collaborative, definitely it should be collaborative environment because it should not hit each other. But if you think about even accessible, all the states should be known, right? That's not liability. Yeah, that's correct. So what Sasikant is saying is doesn't have access to all states. So it's in that if you really think in that way, it's not accessible environment. It's collaborative, it's dynamic, it's multi-agent, uh, but not accessible. Why not accessible? Because it's not accessible accessing all the things that is there. But what is not there is you do not have access to all the states a priori. You can have something uncertainties coming in between. Right? In case of chess, it is an accessible environment because you can really know about all the possible moves and all, right? So that can programmatically done. But when you talk about an environment where something might happen uncertain way, that's not something which you have seen. That scenario is not known. That states is not known, and therefore this is not accessible. So the correct answer is it is in a collaborative environment. It is a dynamic, non-accessible environment, non-accessible, dynamic environment, and it's a multi-agent environment. Okay, all right. So this is fine. We can talk about this. So let's now maybe talk about a little more about problem solving. So we're going to discuss more about planning and all in this fractal. But before that, let's think about like problem solving. So when you talk about problem solving, you make some assumptions. So these are some of the assumptions you typically made to make the life easy. Why it is not static? So static environment is like you at every state things are like at certain position and everything is static, right? So in dynamic environment, in multi-stage, in when you talk about multi-agent environment, it's always dynamic because you do not know where the other guy is, right? So based on that, you have to change your things. So if two cars are running, it itself making the environment dynamic, and then there and on top of that there are uncertainties in the roads which you cannot control. Okay, so problem solving assumption, like these are the assumptions to make life easy, right? uh, because to make something work you may have to come up with some like reasonable assumptions. So these are the assumptions people make. Agents knows world dynamics, right? So this is a priori known. World state is finite, small enough to enumerate. What does it mean? The set of states is finite and you can actually know all the things, right? So something like we're not talking about let's say elephant coming in front of a self-driving car. That type of uncertainties we are just ignoring for a while. Right? World is deterministic. Utility for a sequence of states is sum over path. This will come clear when we talk about some graph things in the tomorrow's lecture. Agent knows current state, so this is fair enough. Like you know the current state where you are. Let's take an example of this robot in the household thing. So I ask the robot, let's say, go to kitchen and bring a spoon. This is the problem solving task I have, right? So in this particular problem solving task, the world dynamics is known to the agent, right? So it's a known house where it is working. It's means everything, every house is mapped in some way to that robot. World state is finite, right? So we are talking about only moving from this room to that room. Some rooms are there, that is finite number of rooms. World is like deterministic, no chaos. Everything is like if you are deterministic in the sense, if you are at dining room, if you move right, uh, you will reach kitchen, and it's not going to change, right? So that's a deterministic notion. Utility for a sequence of states is sum over path. Is, let's understand like this: if you are going to closer to kitchen, then you get some reward, right? And that reward is like sum over everything, sum over the path, right? So you are at some certain position, and you are going to some other position, and some other position, and some other position, and this all this sequence of actions you are taking, uh, if you sum that, that is the overall utility. And agent knows current state. So the robot knows whether it is in bathroom or bedroom or dining room. That is no. This is fair enough assumptions. You know. Another example in the slide we talked about is a map, like route planning in a map, right? So a map is a graph where nodes are cities and links are nodes. This is an abstraction of the real world, right? So again, this is many things when you plan, or when we talk about planning, you do some kind of a abstraction. Let's say you are talking about a robot which can move to different cities, right? For example, so to model that particular problem in a problem solving setup, you will abstractize the problem, right? You will make an abstraction of that problem. And what you make an abstraction, you make that entire problem as a graph problem, right? So a map is a graph where nodes are cities and links are nodes. You really don't worry that this road is not good. This is like a rural road or some other issues, right? So those such issues you just do not bother and make the abstract problem. So agent, what do you mean by agent knows the world dynamics? Map gives the world dynamics starting at X, city X on the map, and taking some road gets you to city Y. So that the entire dynamics is known. What is state is finite and small enough to enumerate. So in this example, the set of cities is finite and enumerable. Word is deterministic. Taking a given road from a given city leads to only one possible destination. So you are at Jodhpur, and if you catch the Jodhpur Jaipur road, you are going to reach Jaipur. That's deterministic. So that's not something going to change. Utility of sequence of states is the sum over path. Utility for a sequence of states is usually either total distance traveled on path or total time of the path, and that's what we try to optimize. As agent knows current city, the example is current city is known, right? So that's very fairly. More formally, this is what a problem is in when you talk about AI setup. The problem has S, the set of states. It's a five tuple. S naught is the initial state, right? O is an operation, which is operation is a function from which changes the state, right? It's a function which changes the state. So it's a function from set of states S to set of states S. Right? So it's a function like this is that. Another one is test, right? So goal test. So what is a goal test? Goal test is test is a function given a state whether it is true or false. So whether you have a reached goal or not, right? So that is the goal test. So for example, if I ask to go to kitchen, so at every state you can evaluate this goal test whether you have reached the kitchen or not. So C is cost, and cost is what we optimize, and cost is nothing but a function between SO S star to real number. So what is SO star? the set of states, the sequence of states and operation, right? So you go to certain, let's say, the coast. For example, if you are going to here, there are, let's say, three cities, Delhi, Jaipur, and Jodhpur. From there is a cost associated with, like, from going to, let's say, Jodhpur to Delhi, Jaipur, is something, operation. From going to go to, from, if you are in Jaipur, go to Delhi is an operation, right? Go to Jaipur to Delhi is an operation. So all these operations and all these states, cities are the states, and there are operations. They all have certain cost associated with that, and some of that cost is the total cost, right? So from Jodhpur to Jaipur, Jaipur to Delhi, the total cost is that much. Or you can directly go to Jodhpur to Delhi. That is another way. So that's all this has some cost associated, and this is a cost is nothing but a function from the set of states and operations to real number. All right. So with this, I will going to stop here. What I'm suggesting is I will, of course, post all these materials. There are a couple of blogs and articles. Please have a look into that, and before tomorrow. And tomorrow we will be starting from this notion of problem. We'll talk about some search, and then start discussing about planning. All right. So, any questions for today? All right. So thanks for joining this class. I'll post these slides and the video. Have a look, and let's meet tomorrow. All right. Thank you.